Good evening, everybody. So, this is the project of switch debouncing on Xilinx Fpga. Okay, what we have done in this debounce experiment is we know that due to the mechanical switching property of this switch, it might go to unwanted states and it might toggle due to the high frequency of our clock. So these high speed toggles are caught by the microprocessor, and a result of this is the input also toggles. For example, if I press this switch, it might go to it might toggle a lot before settling down. So to curb this thing, what I have done is I have divided my clock with the help of counter, and with the help of that counter I have divided the clock and took the output of the divided clock in this LED 0, that is pin number 16. And meanwhile I also passed my clock and my input. The input is taken from this K1 switch, K1 switch, and it is passed through a circuitry as shown below on in the experiment. So what I have done is I have passed that input as well as the low clock through a circuit of 2D flip flop and one and the result and resulting of that circuit, we get a constant output which is not toggling. Since our clock on this FPGA board is 10 megahertz, so I divided it with the counter of 1250000. That is my resulting clock is 8 or no, my resulting clock is 4 hertz, which is shown on this LED. And this uh, clock on this LED is divided by my actual clock, and this low speed clock is driving my input circuitry for switch debounce. So starting with this, right now these LEDs, LED 4 is representing my Q1, LED 5 is representing my Q1 bar, LED 6 is representing my Q1 Q2, and LED 7 is representing my Q2 bar. So as soon as I press this K1 switch, then the 1, the input is equal to 1, that is push button is equal to 1 goes into Q1 as well as the Q2, cause Q1 and Q2 are sequentially connected to each other, and output of Q2 and output of Q1 is taken into AND gate, and the resulting of that AND gate is a constant LED pulse which is taken at this input, LED number 1. But as soon as I release this push button, again my Q1 and Q2 both are 0, and resulting of that LED 1, that is the output, constant pulse output at LED 1 is also 0 according to our circuit. Again, if I press my push button which was given as input to first D flip flop, and sequentially the output of first flip flop is taken into the input of second flip flop, and output of second flip flop along with the output of first flip flop is taken into AND gate, and the resulting of that AND gate basically results in our um, constant signal which is not toggling and which is not debouncing as per the mechanical properties of these switches. Thank you. Again, I am showing you, like, when I press 1, the output on the LED is also 1. When I release this switch, then right now I am giving nothing, that is giving 0 output, and LED 1 is also showing 0 output. As soon as I press 1, then output in LED should also be 1, and this is helping us to achieve switch debouncing. Thank you.